So in Unit 9 so far, we've covered translations, we've covered reflections, and in 9.3, we're talking about rotations. So rotations, as you might have guessed, is going to be turning a point or a figure around in our coordinate plane. And for most of our cases, it's also going to be turned in a certain direction. That's going to be counterclockwise, like that first example. So if you were keeping track of the first coordinates in that question at the top, it's asking, do you notice a pattern? And yeah, you could notice a pattern from that first one, but even better yet, we're going to have some rules to get to each specific point. And those rules are going to be consistent for whenever we're doing these types of rotations. So I'm going to show real quick just our kind of basic gist or definition of what we're doing with rotations. You guys are free to read through that description, but basically the idea is that we're going to be rotating each point, not necessarily the same distance, because if I've noticed points that are further away from our point of rotation rather, our center of rotation, are going to be moving a little bit more than points that are closer. So if I had a point that's very close to that center of rotation, it's not going to be moving too much. But what is going to be consistent is the angle or the degrees that we're going to be rotating these shapes. So we will have rules for certain types of degrees for rotation, and these are going to be some standard rules that we can use every time as long as we're following that amount of rotation, basically. And just like with our previous examples, we could also write this in what we call that function notation, where if I have an input that we're going to call that same preimage, it is going to result in that output or preimage, and in this case, just where this figure is going to end up after rotation. So just to discover our first few rules, again, these are going to be the big ones if I'm moving 90, 180, or 270 degrees. So that would be a quarter turn, 2 quarter turns, or 3 quarter turns. We also do have a rule that if I wanted to spin a circle, or sorry, yeah, spin around in a circle and make 360, technically we could refer to that one as a rule too. But first, I kind of blocked out our rules and just try to talk about what's going on with these 2 points with our preimage and our image. Remember, with our notation, as long as I see that prime symbol, that's going to be in our image or our second figure. And in the first example, notice all these points are going to start off with the coordinate 2, 3. It looks like in our image that coordinate has changed, and we also changed the sign on that coordinate that used to be the y coordinate that we now move to the front, and it's the x coordinate. So we can state that as a rule, as again, we're just going to change the order of those 2 coordinates. X and y is going to flip, it's going to become y and x. And just like we did in that last example, if the previous y value is a positive, once I move that, I'm going to change that to a negative, so we are going to change its sign. As we've seen with other rules, though, again, that doesn't mean that our coordinate is always going to stay negative. It just means that that sign is going to be opposite from when I started. So in this case, since I did start with a positive, that's why it ended negative. If I wanted to rotate 2 quarter turns instead, so instead of going 180 degrees instead of 90 degrees counterclockwise, we're going to see that I can take that same coordinate, 2, 3, but notice that now only the signs have changed and not the actual order. And that's basically going to be our rule for any kind of 180 degree rotation, is we're going to change the signs. And sorry, I actually forgot a sign there when I was making my notes. But yeah, we're going to change both signs of those 2, but we're not going to change anything about their order. So x and y still stays as x and y. But notice again that if I did start with a negative and I wanted to rotate that figure, that would change the sign back to a positive. So again, the big idea is that it's not necessarily finishing with a negative sign. It is just changing the signs of whatever I started with. If I want to do 3 quarter turns, or a 270 degree turn counterclockwise, you could also see this as a 90 degree clockwise rotation. Again, I could get to this point either by going 1 quarter turn clockwise or 3 quarter turns going the farther way around. Usually we're going to refer to it as that counterclockwise rotation, so this would be 270. And again, notice here it's kind of like with our 90 degree rotation, we have changed the order, but notice about our signs, now the second sign that used to be our x and is now our y, now that one has changed signs, not like we did for a 90 degree rotation. So it's going to be a similar rule, although we're going to have to notice that even when I'm flipping, now it's the second coordinate that finishes in that second position that's going to change signs. Compare that to in our 90 degree example, where we saw that same flip, but we changed the sign of the different coordinate. So you do want to be aware of which sign you're changing. Always remember is just the smaller value is 90 degrees, so that means that's our very first number that we start with, like that first result. If it's the 270, or also you can think it starts with a 2, it means that whatever you change to that second position is going to be the one that changes signs. So just a good way of remembering that. Again, yeah, I think if it starts with a 2, you change the second one. If I do want to make a full spin, again, this is going to be pretty rare, but if I want to spin around and end up in the same spot, we don't really have to say anything. 2, 3 is going to end up in 2, 3. So you could say that this is a rotation rule, but whatever I start with, I'm just going to finish with as well. So you just want to know that you're really not changing anything about that point. If I do a full spin, I'll end up back right where we started. So trying to use this in a few examples, I think this is a good example to use the actual coordinates first and figure out where you're going, and then just try and graph it afterwards and trying to decide, does that look like what it should? In this case, it's going to be a 90 degree turn counterclockwise. And the biggest thing to remember for that, if I want to know where these coordinates are going to end up for my image, again, we're going to need the vertices of that image. That's why I have listed off in red. is we're going to have to figure out how to follow that rule. So I didn't state the rule first, but whatever coordinates I start with, under a 90-degree counterclockwise rotation, again, this is where I want to remember it's the first that's going to change signs, and I should flip the order here. As long as I can use that rule consistently with my pre-image points and try to get my image coordinates first, I would do that and then try and decide where that's going to go on your graph. So 1, 1, not too much if I change the order, it's still going to be 1, 1, but I do have to remember, again, whatever started as my first y value is now going to change sign when I move that to the x position. So it looks like now I have a negative 1, 1. If I try to do the same thing with q, looks like it's going to be doing something similar. Q prime is going to be 3, 3, but I do want to change that first coordinate. 4, 1 will become 1, 4, but remembering to change that first sign, it's going to be negative 1, 4. And same thing if I flip here, 0, 3. I can't really do much about changing the sign of the 0, but I at least do want to switch the order of the coordinates, and that's going to put it in the right spot. So let's look and see how accurate this is. Negative 1, 1 is going to be our p prime. Q prime, negative 1, 2, 3, 1, 2, 3 up here. R prime, negative 1, 1, 2, 3, 4. And then S prime, 0, 1, 2, 3. It does look like we just kind of took this figure and made 1/4 turn going counterclockwise, and our figure did end up in the right spot. It's even helpful too, I can't really do this in a video, but if you guys literally turn your page like a 1/4 turn counterclockwise in that same direction, it should also look like you kind of started with that first pre-image and you just kind of moved it over. But yep, that does look like our correct 90-degree counterclockwise rotation. See if we can try that rule out with a different kind of rotation. Nice thing about rotations, they're going to be pretty standard, so 90, 270, or like our last one is 180. This one I did make a change in my notes, so you guys want to make the same thing if this is going to be easier to graph. I changed the coordinates of point F to be negative 1, negative 3, rather than a negative 111. Would kind of run out of room for that on my graph. So I changed the pre-image a bit, but using that same idea of following the rule, if it's a 270-degree counterclockwise rotation, this is where I want to remember that they're going to switch position, of course, but now the second coordinate is the one that's going to change signs. And by second coordinate, again, started out as our first, but now it's going to change position, and it should also change sign. Again, big idea is changing sign, not just necessarily negative. So if I'm doing that with the first coordinate, again, that will flip. Now it's 2 and then 3. And because I changed the sign from a negative to a positive, again, the idea is that it doesn't have to end as a negative. I just want to make sure I change the sign of what I start with. So negative will change to that positive. It looks like the image of F will be at 2, 3. If I follow the same rule here, negative 1 moves to the front. Negative 3 changes sign when I move it to the back. So negative 1, positive 3. Following the same rule again, negative 3 moves to the front. Negative 1 switches and changes sign. 1 moves to the front, and then 0, kind of like with our last example, can't do much about changing that sign, but at least I can change that position. So let's see how this looks. This should look like, again, either a 1/4 turn clockwise or 3 1/4 turns counterclockwise. 1, 2, 1, 2, 3 is going to be our F prime. Negative 1, 1, 2, 3 is going to be G prime. H prime, negative 1, 2, 3, 1. And then I prime, 1, 0. So again, faster way to get to this figure would just be making 1/4 turn moving clockwise. But if I went 3/4 turns around my page, it looks like that would bring us back to this position. So yeah, that does look pretty accurate for the 270-degree counterclockwise rotation. Let me just add in the labels here as well, just so that's a little bit less confusing. F prime, G prime, H prime, and then I prime. You do want to make sure which coordinate is which, because if I asked, like on this figure, where did that end up? You want to make sure you're just not identifying the wrong vertex there. So for this last example, kind of like with our other examples before, what I've done is I've kind of blocked this out just to make this video a little bit quicker. I do want to see if you guys can get through this and do it yourself, again, following this last rule for 180-degree rotation. I'm going to be uncovering the answer in just a second. I, again, suggest you guys try this first, see how accurate you were following those same steps. So let's take a look. If I do want to rotate this shape 180 degrees, again, the first thing you want to be aware of, now that I kind of got rid of some of that, I guess, this is going to be D prime, or sorry, D rather, that we start with, over at negative 2, positive 1. You do want to just make sure you're following the right rotation rule. If it's a 180-degree rotation, we know that we're not changing anything about the order, but we are just changing both signs. And that means, again, if I started, if it was negative 2, positive 1, we're not going to change anything about that order. We're just going to change the sign either from negative to positive or positive to negative. Coordinate you guys should have arrived at for D prime was 2, negative 1. Following that similar rule, E prime was a negative 3, positive 2. F prime, negative 1, positive 4. Again, not changing order, but changing signs. And it does look, I kind of just took this triangle, it looks like, and rotated it twice in either direction. And that's going to make that second image. Again, not quite a reflection here, even though sometimes it is kind of easy to confuse 180-degree rotation with a reflection. But in this case, it does look like if I turn this and I turn this twice, it does kind of look like it's facing the opposite direction. So that is a rotation still. So again, just make sure you're comfortable with the rules. If you guys can follow the rules for those rotations, get the coordinates first. That's going to make this a lot easier to graph.